Morning. I want to talk to you guys about enzymes today and tell you a little bit about enzymes and how they work. Before we really dive into enzymes, I want to introduce you to two other concepts, chemical reactions and basically what enzymes are. And so enzymes are a type of protein. And so this blue molecule here, this is actually an enzyme, and enzymes are made of thousands of atoms, but actually enzymes are proteins. And so proteins, remember, they are a polymer of a bunch of amino acids. And so the amino acids is the monomer, and these actually combine to make hundreds of atoms combine to make these amino acids, which combine to make a polymer. And these polymers actually fold in on themselves, so they kind of look like a big mess of a molecule like that. But these are basically the polymers of amino acids. Well, enzymes are actually a type of protein. Not all proteins are enzymes, but all enzymes are proteins. And so here you can see that proteins actually have different functions. Some of them are enzymes, some of them are active in defense. Others help get things in and out of our cells, especially in the cell membrane, you'll learn in the coming weeks. Others are involved with cell communication. Others are involved with support in our body systems. And then finally, other proteins are involved with more structural purposes. But we mainly want to talk about enzymes. And so again, all enzymes are proteins. Now, let's take a minute and talk about chemical reactions, and we'll get back to enzymes. Chemical reactions are basically all of the reactions that go on in life. And there's a bunch of different kinds. We can take one molecule and another molecule, and they can go through a chemical reaction to combine and make one product. So when we talk about chemical reactions, these are actually reactants, which are the molecules that we have before we go through our reaction here, and these are actually the products. Now notice that sometimes we can combine two molecules to basically form a product, or we can have one molecule that will go through a reaction to form two products, or we could have two reactants that go through a reaction, but they have chemical reactions that basically just change them just a little bit. So they don't necessarily have to form one product, but there are still products that are made, and they may very well look similar to their reactants, or they could look very different from their reactants. Now, chemical reaction graphs, we generally take chemical reactions and divide them into two types. There are energy absorbing reactions, and then there are energy releasing reactions. So I kind of want to talk to you about these graphs a little bit just to get an idea of what's going on. So let's zoom in a little bit on this energy releasing reaction. Now if you notice, you basically have reactants here, and our reactants here could generally be two molecules, and they're going to go through the chemical reaction. So if we look at the y-axis of this graph, the course of the chemical reaction, or you could think of that as going over time, and then basically we end up getting products. And it might very well be that A and B are going to combine and make just one product here. Okay. Now if we look at this on a different way, and we follow the energy line, if you will, or if we follow where the reactants are and we follow where the products are, this area over here is basically considered our energy level, or our available energy in these molecules. And so remember, the reactants are molecules and the products are molecules. But in this particular graph, our reactants are actually higher, at a higher energy level than our products. And that's important here, because what that means is our products have a lower energy level than when we started with the reactants. And if that's the case, that means that a lot of energy had to come out of this reaction and basically leave the reaction. And that's why we say this is an energy releasing reaction. So remember, when we see the products are a lot lower in energy level than the reactants, we know that energy basically left this reaction. And so here we actually call the space activation energy. And this is really the amount of energy it took for these reactants to get into a chemical reaction and finally get to the point where they will make products. It's really the energy level it took. And we measure activation energy by the amount of energy going from the reactants to the height of that chemical reaction, and really how much energy did it take to actually absorb to get to this level. Now remember, every chemical reaction is going to need a little bit of energy to get going, but then what happens at the end is they either absorb more energy than it took overall, or they're going to release a lot more energy in the end. And in this particular reaction, if our products are lower than the reactants, we're going to release a lot of energy. Okay? If we look at this particular graph, this is the energy absorbing reaction. And I want you guys to note that here our reactants are a lot lower and our products are a lot higher. And so if we bring our products over to the the y-axis, and we look at where they are in the available energy, our products are higher. And that means that we had to absorb a lot of energy into this reaction to basically go through this reaction, but we never let out all that energy we absorbed. In fact, we absorbed way more energy into this actual reaction than we released. So that's why we call this energy absorbing reaction. Okay, so basically enzymes help chemical reactions go faster. These chemical reactions are already going to happen in nature. They're already going to happen all the time. In fact, an analogy would be if you've got homework to do and the last thing you want to do is do your homework, it might take you 5 hours to do it. And you might get on Facebook or Twitter or things like that. Maybe help your mom set the table because you might rather be doing that than homework. So it is something you're eventually going to do, but it might take you 5 hours to be done with it. But if your mom offers you concert tickets to, say, Imagine Dragons or another favorite artist, you might actually decide to hurry up and do that homework. In fact, she might even say, if you can finish your homework in an hour, I'll give you these concert tickets. And so in a way, the concert tickets kind of act like a catalyst. They basically helped you do the same thing you were going to do, but you were going to do it a little bit faster. In fact, you've got the same homework. Your homework doesn't change at all. It's actually going to stay exactly the same. And you're going to get the same finishing product as if you had concert tickets or not. And so think of enzymes that same way. You're going to start with the same reactants. The enzyme is not going to change your reactant at all. And the enzyme is not going to change your final result. If your homework were math, 1 plus 1 is always going to equal 2. An enzyme won't change that. But what this enzyme might actually do is it helps you get that reaction done faster. Okay, so when we look at that actual chemical reaction on a graph, here's what we've got. Again, here's our energy releasing chemical reaction. So our products have a lot less energy than our reactants, okay? Now the normal reaction basically goes like this. Follow the blue line. Our reactants start out, they have to absorb energy to get going. So it's going to take a little bit of energy to start this reaction, but then once that reaction gets going, we release a lot of energy. And the fact that our products are lower than our reactants means that we're releasing all of this energy right here is being released on this graph, okay? And so basically, if we do it with an enzyme, look what happens. If you follow the red line, what's lower? Our products are the same. Actually, here, our products are exactly the same. They're no different. And our reactants are exactly the same. But the one thing that's different is the activation energy level. So if you look at this spot right here, between the height of the reaction and where the reactants were, and we look at it with an enzyme, we'll see that this is a little bit different. And what this means is it took less energy to get this reaction going with an enzyme, okay? So enzymes basically lower activation energy. Same reactants, same products, they just went a whole lot faster. All right, so enzymes bring the reactants together using less energy. And so with less energy, they come together a lot faster and they happen a lot quicker. Now remember, a lot of the reactants in our bodies, actually a lot of the chemical reactions in our bodies would take a long time. In fact, sometimes years or months, and we actually would die if that were to happen. If our bodies couldn't make the things that we make in a matter of seconds, we would not be able to live. Our metabolism wouldn't be able to sustain itself. And so enzymes are very, very critical in general life reactions to help them happen a lot quicker. And so again, we have the same reactants, the same products, but this red line really represents an enzyme as allowing that reaction to happen a lot quicker. Okay, so basically, reactions without an enzyme, we've got this one molecule and another molecule, and they turn into this purple product, is exactly the same as a reaction with an enzyme. Same molecule, same product, except with our enzyme, we generally indicate that right above our arrow when we talk about a reaction, and they happen a lot faster. So while this might take a month for this reaction to take place, maybe in a vial, with a certain enzyme, it might take a matter of seconds. All right? So that's just a quick background about proteins and a type of protein called an enzyme and chemical reactions. The next time we talk, we're actually going to talk about how actual enzymes work. We're going to talk about the enzyme substrate complex. And so this is actually a substrate which is needed to combine with an enzyme, and we'll talk about exactly how that works. I hope that helps, and I'll see you guys next time.